This was in the 1970s, a simulation of the Soviet landing on Venus for a successful login and give the world its true colors. Soviet scientists before and after, numerous improvements have been made to the Venus probe. Let's take a look. As there was no substantive progress on the first 3 occasions, so here we'll ignore. This is Venus 4, launched in 1967. At the time, little was known about this mysterious planet. Scientists even think that underneath its thick cloud cover, it's a world not so different from Earth. For example, standard atmospheric pressure is suitable for the temperature of the environment in which organisms have evolved. But after the data returned by Venus 4, they found out the hard way. When the Venus 4 was traveling at 40,000 kilometers per hour, as it passes through Venus atmosphere, deceleration parachute open. The antenna on top starts transmitting data at the same time. At the outset, scientists find Venus atmospheric pressure very close to Earth's. So is the temperature, around 30 degrees Celsius. But then everything suddenly changed. As the height of the detector is gradually reduced, the data being transmitted back is starting to get wild. Atmospheric pressures are rapidly spiking to 10x, 20x, and the temperature has skyrocketed to over 200 degrees Celsius, until the Venus 4 suddenly exploded and disintegrated. All data transfers have been interrupted, and the last set of data was made public. Venus' atmosphere is 22 times thicker than Earth's. The temperature is 250 degrees Celsius, and that's without landing. At this time, Soviet scientists, finally, a glimpse of this mysterious planet. It's not an Earth-like planet. It's a brutal hell. But that didn't scare the scientists. Instead, it's fueled their desire to explore. Early detectors were relatively simple in design. The main body is a titanium sphere with a diameter of 1 meter. The space inside is pressurized. Pressure is about 25 Earth atmospheres. It houses the detector's main scientific instruments, used to analyze the atmospheres of target planets and for temperature measurements. Additionally, the probe is not equipped with today's mainstream reverse thrusters. Instead, it's all about resistance and a parachute to slow it down, and finally landed. But Venus' atmosphere is too thick. Venus 4 didn't cross the atmosphere fast enough. It's like walking through mud, despite eventually slowing down to 18 kilometers per hour, much slower than expected. But he's been in the atmosphere too long, for an hour and a half. Under the constant blows of heat and pressure, eventually it bursts and disintegrates. At this point, the scientists realize that keys to solving problems. It's about shortening the probe's retention time in the atmosphere. That means the probe has to pass through the atmosphere before it disintegrates. It's easy to say, but it's hard as hell to actually implement. Because Venus' atmosphere is too thick, there's too much resistance. The Soviet Union had no choice but to turn to the United States. They're going to send a fax to NASA. Hopefully, the Americans will provide a special heat-resistant material in order to increase the detector's survivability. But the Soviets didn't. In order to reach the surface of Venus before disintegration, Soviet scientists redesigned the detector, also known as Venus 7. He's traveling through the atmosphere a whole lot faster. It's a genius method. They put a belt on the parachute cord. Inception. The parachute, though, was released, but all he can do is stay contracted. In order to reduce the resistance, speed up the landing. Leather bands are made of a material with a melting point of 200 degrees Celsius, so only the temperature exceeds him. The parachute can only be fully deployed, since the pressure and temperature on the surface of Venus are still unknown. So the scientists have additionally modified the probe. The thickness of the titanium spheres is tripled, so the Venus 7 can withstand the terrifying pressure of 180 atmospheres. In 1970, the probe entered the atmosphere of Venus as expected. He's slowing down and releasing his parachute. That's where the leather strap comes into play. The Venus 7 is landing at a much higher speed. As the temperature rises, leather band melting, parachute fully deployed. When it's only about 3 kilometers above the surface, the parachute was torn and rendered useless. The probe began traveling at 60 kilometers per hour, slamming hard into the ground. Unfortunately, the Soviet Union has failed once again. That's a lot of force. But later, when looking at the relevant data, scientists have found a surprise. The probe was on the surface for 23 minutes after impact. It's been transmitting a weak signal. It's weak. It's not like the instruments are malfunctioning or anything. It was the force of the impact. It causes the angle of the antenna to change. That's right. Simply put, the antenna isn't pointed at the Earth. The signal is weak, but the scientists analyzed it anyway. As it turns out, they found temperature of the surface of Venus. It's a horrible 500 degrees Celsius. This data is critical. The heat is the biggest roadblock right now. So the next thing the scientists did was to improve the detector, also known as Venus 8. They've added a new cooling system inside the sphere. That's what these 2 pieces of lithium nitrate are. It's a salt-like substance with a very high heat of fusion. The heat of melting is the heat of melting of a crystal per unit mass as it melts. Heat absorbed to become a liquid substance of the same temperature. Due to the very high heat of fusion of lithium nitrate, So when it goes from a solid to a liquid, capable of absorbing large amounts of heat from its surroundings, finalizing the cooling effect. After improving the material of the parachute, Venus 8 has successfully landed on the surface of Venus and lived and breathed on it for a whole hour. Although the Soviet Union succeeded this time, but the world still doesn't know. This is a planet with an extremely hostile environment. What does it look like? In view of the above, the Soviet Union developed the Venus 9 based on the 8. He's going to give us the first picture of Venus. The Venus 9 design is nothing like it was before. He's not equipped with a parachute. In its place is a pair of large deceleration wings. Not only that, but Venus 9 also added a set of landing legs to absorb the massive impact of the landing. These designs work, but the most important thing is the camera system. 2 movable cameras on each side of the detector. They can take 360-degree panoramic photos of their surroundings. But designing a camera is capable of withstanding the extreme temperatures and pressures of Venus. Another big challenge. The Venus 9's camera was placed inside the pressure vessel. In addition, 2 periscopes attached to it, deep inside the extra thick pressure vessel on the outside. The periscope has a small lens at the end of it. It can rotate and scan a 180-degree plan view. When light enters the interior, the periscope reflects light back to the internal lens. If this happens, then deviations due to extra thick pressure vessels are then corrected. Both cameras come with a heavy-duty lens protector. Once the landing is complete, they'll eject themselves. Regrettably, on top of the Venus 9, one of the ejector mechanisms is malfunctioning. Only one of them made it. Nevertheless, he still took the first pictures of the surface of Venus. On subsequent missions to Venus, Soviet scientists made a number of additional improvements to the camera and took more high-resolution color photographs of the surface of Venus. It's worth mentioning that, for Venus 14, the scientists also put a microphone on it. The Soviet Union's series of Venus probes logged in a total of 8 times. A lot of valuable data came back each time, and a strange picture. And after 50 years, we don't visit this golden planet anymore.